Good morning, my dear student. Mr. Some of you, teacher of chemistry. As per our curriculum, we will continue that we have studied before in the second term. As we know, first unit speaking about the thermochemistry, lesson number 1, heat content, that we have finished before. Lesson number 2, forms of changes in heat content. We will continue lesson number 2. There are 3 points. Number 1, heat change accompanying physical change, standard heat of solution and standard heat of dilution, that we have finished before. Number 2, heat change accompanying chemical change, standard heat of combustion and standard heat of formation. Standard heat of combustion, we have finished this point, and we will study the standard heat of formation today. The third point, speaking about HESS'S law. What is the standard heat of formation? Standard heat of formation regarding the formation of any compound is the quantity of heat released or absorbed when 1 mole of a compound is formed. Let's take an example, formation of water molecule. 1 mole of hydrogen gas reacting with half mole of oxygen gas, producing 1 mole of water liquid. Standard heat of formation of this reaction equal to negative 287.5. That means that a released heat during this reaction equal to 287.5 kilojoule per mole to form 1 mole of water. As we know, a negative sign in the delta H refers to exothermic reaction, and the positive sign of delta H refers to endothermic reaction. And the difference between exothermic reaction and endothermic reaction in the formation of the compound is very important, because when standard heat of formation of any compound carrying a negative sign, it will reveal that this compound is stable, rather than another compound like hydrogen iodide or hydroiodic acid. The standard heat of formation of this compound carrying a positive sign, which is unstable. So any compound when formed, if it releases heat and the delta H carrying negative sign, so it will form a stable compound like hydrogen bromide or hydrobromic acid. And if any compound carrying positive sign, when it formed, this compound is unstable. How can we calculate the standard heat of formation? We have to use this equation to calculate the standard heat of formation. This relation that we have studied before, delta H equal sigma H product, or summation of heat content of the products minus the summation of heat contents of the reactants. Let's take an example. Calculate the change in the heat content of the following reaction. Hydrogen sulfide plus 4 moles of fluorine gas producing 2 moles of hydrofluoric acid plus sulfur hexafluoride. The heat content of each compound H2S equal negative 21, HF equal negative 273 kilojoule per mole, SF6 equal negative 1220 kilojoule per mole. We note here that the fluorine has no heat of formation because the scientists suppose that each element, when formed, the standard heat of formation of this element equals 0. This rule for elements only. The standard heat of formation of any element equal 0. So the standard heat of formation of fluorine element here equals 0. Let's apply the rule delta H equal summation of standard heat or summation of heat content of products minus summation of heat content of reactants. Here the product 2HF 2 moles multiply the heat content of this compound HF, which is negative 273. 2 multiply negative 273 plus the other product SF6, the heat content of this product negative 1220. This for the summation of the products minus sigma reactants. The first reactant H2S, the heat of formation of this compound negative 21 plus 4 multiply 0 for fluorine. By calculating this equation, the resulted heat delta H of formation or standard heat of formation of this reaction equal negative 1745 kilojoule. Let's go to the HESS'S law. HESS'S law, the very important scientist who's speaking about the standard heat of formation of some reaction that we faced a difficulty in its calculation. The HESS'S law says that the heat of the reaction is a constant amount in standard conditions, whether the reaction took place in one step or a number of steps. So we have to use a mathematical relation that HESS'S law calculate the change of heat of the reaction through this mathematical relation. Delta H of this reaction equal delta H1 plus delta H2 plus delta H3. Each delta H of these standard heat of formations including one reaction in the steps of the formation of the main reaction. Let's take an example for more illustration. How we can calculate the standard heat of the reaction using HESS'S law. Example, calculate the change in heat of the following reaction. Note that this reaction, carbon solid plus half mole of oxygen gas producing carbon monoxide gas. We want to calculate the heat change of this reaction using these two reactions. The summation of these two reactions will produce the resulted reaction. Each reaction contains its own delta H. The first reaction, the delta H equal negative 393.5 kilojoule per mole. The second reaction, the delta H equal negative 283.5 kilojoule per mole. How can we calculate the delta H of the main reaction here? First of all, look at the product here in the main reaction, carbon monoxide. Where is the carbon monoxide here into these reactions? Carbon monoxide in the first reaction or the first equation is not available, but in the second equation, the carbon monoxide present in the reactant. Although the carbon monoxide present here in the product. So the first step, we have to invert the equation 2. We have to invert the equation 2, make the reactants in the product and the product in the reactants. This is the first step. Invert equation 2 to make carbon dioxide in the reactants and the carbon monoxide with half mole of oxygen in the product. By inverting this reaction, the delta H must be inverted its sign. It was a negative sign, we have to make it in the positive sign, okay, due to this inversion. And we made this inversion to make a carbon monoxide here in the product. Looks like a main equation. The second step in the first equation, look at the main equation, carbon solid present in the reactant. The first equation also the carbon solid present in the reactant, so the first equation as it is, no change or no amendment occurs in it. By adding these two resultant equations, we will obtain the main reaction. Let's say, by adding the two equations, equation number 1, CO2, giving carbon monoxide plus half mole of oxygen gas, and the delta H of this reaction equal positive 283.5. The second equation, carbon plus oxygen, carbon dioxide produced, and this is the delta H of this reaction. By adding these two reactions, we note here, by thinking about algebraic equation, the carbon dioxide here in the reactant and the carbon dioxide here in the product. We can cancel this carbon dioxide with this carbon dioxide. Okay, like this. We cancel this carbon dioxide and this carbon dioxide. Also oxygen gas here in the product and oxygen gas in the second reaction in the reactant. We can cancel this half mole of oxygen gas with only half mole of the oxygen gas producing half mole of oxygen gas. Like 1 minus half equal half. Okay. The remaining components, carbon solid, written here in the result, half mole of oxygen gas produced here or remained here in the reactant, and finally in the product carbon monoxide here. This reaction is the final reaction that we won't reach it. By adding this equation, we have to add the delta H of each reaction. Positive 283.5 plus negative 393.5. By adding these numbers, the resulted delta H is negative 110 kilojoule per mole, and this is the final result. Thank you very much for listening, and I'm waiting for your questions in our WhatsApp group. Thank you, my student.